right, so like I said, questions from the review. Let's start with page number 1. What do you got?
7.
Number 7. All right, let's start with number 7. Okay, so if we take a look at this problem, when you do anything from 5 through 11 on the review, you're working back with equations, rectangular to polar, polar to rectangular, which means, in this case, we're starting in rectangular because we've got x's and y's. We need to get to polar form, which means we need to get to r's and thetas, okay? Somebody asked yesterday, how do you know when you're done, okay? If it's going to polar form, it's actually easier to know when you're done versus rectangular. And that is, polar form, you want to end up in one of 3 places. Most of the time, it will be r equals. Okay, that's when you know you're done, when you're in r equals form. Okay. Second option is you might have r squared equals. Or the only other option would be, if you don't have any r's in the equation, you might end up with theta equals. Okay, those are kind of your 3 options of how you know you're done putting something in polar form. R equals, r squared equals, theta equals. So this one, the equations that are on the board are the ones that we're going to use. We got to try to manipulate the equation a little bit so we end up with one of those. Remember when we did this, we made substitutions, okay, is what we did. So sometimes we substituted for x, sometimes we substituted for y, sometimes we substituted for x squared plus y squared, okay. Sometimes we substituted for y over x. Okay? Those are kind of the things that we're working on. In this case, first quick heads up, just to give you another way of looking at this. This equation is the same thing. Whenever the x is on the top, it's the same thing if you kind of pulled it off to the side. So this is the same thing as y equals negative square root of 3 over 3x. Those are the exact same equation. The reason why I did that is, here's what I see, and again, there's multiple ways to do this. This is the way I think is the easiest. If I now take both equations and divide it by x, on the right-hand side, the x's will cancel out. On the left-hand side, I now have y divided by x, which equals what? There's your substitution. Y over x is tangent of theta. Okay? So there's a substitution where we can get the x's and the y's out, and now we move into thetas instead. Okay? So that means this is the tangent of theta equal to the negative square root of 3 over 3. And now, to finish this off, now we basically solve the equation. That means we look on the unit circle and we say, all right, where does theta equal negative square root of 3 over 3? And I believe the answer is 5 pi over 6. Yep. So I end up with theta equal to 5 pi over 6. And there's your, remember we said, there's how you know you're done. You're in theta equals form. Okay? Rather than, we didn't have any r's to solve for, so we ended up in theta. Right? So there's problem number 7. There's that idea. Yeah, let's take a look at number 5. This will be a good one to take a look at. Okay, so this one, same idea. We've got x's and y's. We need to get the r's and thetas. And again, there's a couple of things we could do. People that I've helped on this between yesterday and today. Some people took the x's and the y's out right away. And instead of x, put in r cosine theta. Instead of y, put in r sine theta. You can do that. That's perfectly fine and still get to the same end result. I personally think it's easier if you start by leaving the x's and the y's there, and let's actually square this out. Let's actually FOIL both of these out, okay? I think it's easier to FOIL out with the x's and the y's than it is with r's and thetas and cosines and all that stuff. So if I multiply out x plus 2 squared, we get x squared plus 4x plus 4. Plus, if I multiply out the y minus 1 squared, we get y squared minus 2y plus 1 equal to 5. So even though it looks worse, we're about to make it much better. We're about to make it much nicer, okay? As we now go through, and let's start with the constants. Notice we have a plus 4, plus 1 gives you 5. If I were to subtract that to the other side, those all cancel out. So the 4, the 1, and the 5, this all now becomes 0 if you subtract those over to the other side. And now here's the rest of what you can do. Now if you take a look, I've got x squared plus y squared. What does x squared plus y squared equal? That's r squared. We can pull that out and put an r squared in there. I have a 4x. We can take out the x and put in r cosine theta. I've got a minus 2y. I can pull out the y, put in an r sine theta. So we have minus 2r sine theta. And then we had said already it's equal to 0 on the other side. Now, one of the reasons I was glad that you asked this question is because if you end up with an equation that has r squareds and r in it, remember we said we want to either end up with r equals or r squared equals. Well, in this case, we've got r's and r squareds. Anybody tell me what's the easiest way to get this down to one or the other? Yeah, you just divide everything by r. And therefore, if you divide all of this stuff by r, as a matter of fact, maybe I'll do it a different way, just to show it a different way. Divide every term by r. That's not what I wanted. Oh yeah, I could do that. That's a better idea. Thank you. There you go. So if we divide that by r, if I divide this term by r, if I divide that by r, and then just to keep things balanced, you do have to divide technically the other side by r as well. Now what we end up with, first term becomes r, plus, second term then the r's cancel out, and you're left with 4 cosine theta. Third term, the r's cancel out, and you're left with minus 2 sine theta. And then 0 divided by r is still 0. And now the only thing left to do, we want to end up in r equals form. Take the two terms that don't have r in them and add and subtract them to the other side. Okay? So ultimately you get r equal to negative 4 cosine theta plus 2 sine theta. And there's your equation in polar form. There's the equation in polar form. Okay? Like I said, anytime you end up with something that has r squareds and r's, you can always divide out an r to get it down to help yourself out a little bit. Okay? Other questions? Anything else you want to go over? Anything else at all? Now's the time to ask. Yeah, we're going to do one of the 8 through 11. Let's do, anybody have a preference? 10 or 11? Let's do one of those two.
10. 11. 10. 11.
We can do them both, it's fine. They're pretty quick. All right, let's take a look at 10 to start with. Okay, so now in this last section, now we're in polar form. We got to get rid of the r's and the thetas, and we need to get to the x's and the y's. Again, using those same equations. Okay? So, you got to, again, try to manipulate this a little bit so we end up with some either r cosine thetas, r sine thetas, r squareds, or tangent of theta, something like that. We need to make substitutions again. So when I see this, first thing I see when I see this, I see a tangent of theta right there, which means more than likely I can take that out and put a y over x in its spot. Okay, I'm not going to do it on step 1 because I want you to see the process, but that's coming. Okay, the idea is we're going to end up taking that out. The other thing that I see right away, I see a secant theta. We don't have any equation that has anything to do with secant theta. But what is secant of theta? It's 1 over cosine theta. We do have equations that have cosine theta in it. So I'm going to rewrite this to begin as 3 tangent theta times 1 over cosine theta. Now, we made it a little bit messier because we put a fraction in there, which means how do I clear the fraction? Let's get rid of that. Yeah, multiply everything, both sides by cosine of theta. That'll get rid of that fraction. So on the left-hand side, then I end up with r cosine theta equal to 3 tangent theta. When you multiply, the cosine of theta will go away, the 1 over cosine of theta. And now if you take a look at where we're at, now we're direct substitutions at this point. R cosine theta, that's x, equal to 3 tangent of theta, that's y over x. I'm going to do it as 3y over x. And again, the question came up yesterday, this morning, and same today as well. How do you know when you're done, when you're in rectangular? Okay? What I would say is this. I would not quite stop there only because you got x's in 2 different spots. Okay? But generally, once you get to having everything x's and y's, and I'll show you on like number 11, for example. Once you get to x's and y's, you're pretty much at that point where we need to be. At least combine like terms and clean it up a little bit. Like here, that's why I'm not going to stop. Think of this as x over 1, and just cross multiply. Okay? So we have x squared equal to 3y. I'm perfectly fine if you want to stop right there. Okay? I'm happy with. I'd give you full credit with that answer. Okay? But if you look at the answer on the actual packet, they solve for y. They put it in y equals form. So the solution that they had was y equals x squared divided by 3. Okay? They just put it in y equals form. That's perfectly fine, but I don't feel like it's really totally necessary either. So if you stop there, I'm fine with you stopping there. Okay? Like I said, I give you full credit for that. Okay? So the ones that start in polar form, I would say are a little bit more difficult because you have to try to manipulate them. And it's the idea, without the practice, you have to be able to kind of practice your way through of like what strategies do I use to end up with what I need. Okay? Let's take a look at 11. Let's start there. Let's do that one. All right. Same thing again, same general idea again. R's and thetas, I need to get some substitution. Any idea, what should we do first on this one?
Take out the cos. Divide by. Oh wait,
Divide by some.
You want to try to get to, what do we look like? We're close to some things here.
No.
We got an R. Okay, we could try to get to r squared and then make a substitution.
But we just use the 2 top equations.
You can use any of these,
Maybe you multiply.
I know,
but we are going to use those, yes.
That's what I'm
Multiply
trying to tell you.
everything by r, maybe.
That's a good idea.
Oh.
Here's why multiplying everything by r is probably the best idea.
How can you use R?
Here I'm going to get an r squared then, which I can substitute. Here I'm going to get an r cosine theta, which I can then substitute. And here I'll end up with an r sine theta, which I can substitute. So in one step, if I take this whole thing and multiply by r, we end up with r squared equal to 6r cosine theta minus 2r sine theta.
Ooh.
And now, by doing that, now I can make a bunch of substitutions. Take out the r squared, put in x squared plus y squared. Take out the r cosine theta, plug in an x. We got 6x. Take out the r sine theta, plug in a y, minus 2y. And this one in particular, by the way, I would absolutely not go to the answer that's on the answer key.
So this is good.
This is as far as I would go. Okay?
So the answer
If by the way, there was, let's say, x's or y's or any like terms you could combine, I would expect you to combine those. But otherwise, you can leave it just like that. Okay? There is one other problem I do want to do, just to make sure that you see it, and that is problem number 3. I want you to see the work. I want you to see the process.
I think I got this. Wait, number 3? No, just kidding.
Okay. And reminder again, on the test, you will have your graphing packet to help you with the graphing problems, and you will have your unit circle. That's it. You won't have any calculator at all in order. That's why I want to do this one, because this is kind of messy, but you need to be able to do these types of problems by hand without a calculator as well. Okay, so I want you to see this one. Directions, say these are rectangular coordinates, change them into polar, which means this is x, and that's y if we're in rectangular form. We need to get r and theta. To go, when you're dealing with coordinates, by the way, the top 2 equations will take you from polar easily into rectangular, because you'll have r and theta. All you got to do is plug them in and get the corresponding x and y. The bottom 2 are the ones you want to use to get in from rectangular into polar, because I can use the first equation to come up with r. I can use the second equation to come up with theta. And that's what you need is r and theta. So let's start with that. We have x squared plus y squared equals r squared. And we know both x and y. I can plug both my x coordinate and my y coordinate in. All right, so if we take a look, this is why I wanted to go over this problem right here. 2 reasons. This is one of them. Because if this was a problem that was on the test on Monday, you need to be able to do this by hand, okay? Because you don't have a calculator. But you're going to see that it's really not that bad if you just work your way through it. How do you square a fraction? Square the top, square the bottom. This is 9/4. That's all that is. Plus. Second one's a little messier. Bottom is still 4. We have that. But when you square the top, because you've got 2 things multiplied together, you're just going to square each part and then multiply those answers together. So 3 squared is 9. Square root of 3 squared is 3. And 9 times 3 is 27. And if you look, when I add those together, then what do I get? 36/4, which is 9. R squared equals 9, which means R is
3.
Yep. That's why you need to be able to do it by hand, because you can.
Okay.
So we end up with 3 equal to R. There's the R. Okay, we found that part of it. We need R and we need theta. I've got R. And now theta is going to come from the other equation, the tangent one.
Oh, yeah, the tangent.
Tangent of theta equals y over x. And once again, I have both x and y that I can plug in. Again, it's going to be messy at first, just like it was when we found r. But then again, it cleans everything up. So if we take that, tangent of theta equals negative 3 square root of 3 over 2 divided by negative 3/2. How do I simplify that down a little bit? That's too messy. Multiply by the reciprocal. Rather than divide by that fraction, multiply by the reciprocal. The good news is almost everything cancels out. So I'm going to multiply by negative 2/3 rather than dividing by negative 3/2. And if you take a look, tangent of theta equals, oops, hang on. Where'd I go? There we go. Tangent of theta is, negative times a negative is positive. That 2 and that 2 cancel out. That 3 and that 3 cancel out. Must be touching the smartboard. I end up with square root of 3. And now we go to the unit circle and say, what value of theta equals the square root of 3? Okay? And your answer for theta then is, one answer is what? Pi over 3 is one option. What's the other one? 4 pi over 3. So the next question then is, how do I know which one is the right one? This is the last part.
They're both negative.
You go back to your coordinates. They're both negative, which puts you in which quadrant? Quadrant 3. So you use the quadrant 3 angle. There's your theta. So your answer to this problem is, remember when you have coordinates and polar coordinates, they're always in the form r comma theta. And you have r and theta now. So your final answer would be 3 comma 4 pi over 3.
And this has to take me like
Yeah. You could put them in degrees. I'd accept it in degrees too. If you did, let's say it was pi over 3 and you put 60 degrees instead, that's fine. Okay? I don't really care whether it's radians or degrees. Okay? All right. That should at least give you kind of an idea. Notice, by the way, number 4 on the review. It's the exact same problem, just the coordinates are positive instead. So what's the only difference between the answer?
it's pi 3.
Theta is the pi over 3 instead, because it's the first quadrant angle instead of the third quadrant angle. That's the only difference. Yeah. Okay? All right. With the rest of the time today, what I would like you to do then, number 1, work on your review. I have a second review that I will hand out to you as well, that you can work on, give you just more practice problems. And then if you have any questions as you're working your way through today, you have the opportunity to get some help and go from there. Okay?